In this video, we'll look at integrating a power of sine or cosine, and the example I've chosen is the integral of sine to the fourth of 2x dx. The first observation to make is that the degree is even. And when I see even degrees exclusively in powers of sines or cosines, I'm going to want to use these power reduction identities. I've reviewed them for you right here. Sine squared and cosine squared of x can both be written in terms of cosine of a double angle. They are very similar identities. Notice the only difference is the sign that appears in the middle of the expression. In order to take advantage of the 1 for sine squared, I'm going to turn sine to the fourth into two factors of sine squared. So first, I'm going to rewrite the integrand as sine squared of 2x times sine squared of 2x. Each occurrence of those sine squares are going to be replaced with the right-hand side of this identity. We have to be a little bit careful here. The angle in sine squared of 2x is already twice x. So it's going to be 2x in here, resulting in 4x on the other side. I have to double the angle as I apply the identity. So in the first instance, it's going to be 1 minus cosine of 4x over 2, and then we'll have the same thing for the other factor as well. We now have what looks to be something significantly more complicated, but if we expand this out, things will have improved significantly. In the denominator, I have 2 times 2, so all over 4. I'm going to FOIL everything out. I'll have 1 times 1. Then I'll have minus a cosine and minus another cosine from my outer and inner term, so I'll have minus 2 times cosine of 4x. And then my last term will be the cosine times the cosine, so it will be plus cosine squared of 4x dx. Let's separate this into individual terms. So the first one is 1 over 4. Then I have minus 2 over 4, that's minus 1/2 cosine of 4x. And then I have 1/4, 1 over 4, cosine squared of 4x. All of these are terms that I can integrate. 1/4 is constant. 1/2 cosine of 4x is something I can integrate. It will involve sine of 4x. However, this term is still an even degree, so we'll have to think about that in a moment. Let's integrate 1/4. I'll get 1/4 x. The second term is 1/2. It will be sine of 4x, and I have to divide by 4 to account for the 4 that appears in the angle. I still need to integrate 1/4 cosine squared of 4x. However, to do the integral of cosine squared, because it's an even degree, I'm going to apply the reduction formula for cosine. Notice the angle is already 4x, so it's going to double to be 8 times x now. So let's write out the first couple of terms. Then I have 1/4 times my integral. I'm going to apply that identity. It'll be 1 plus now cosine of 8x over 2. Finally, we're going to expand out these terms in this integral and do the same sort of thing that we just did above. So just writing out the first couple of terms. It's going to be 1/4 over 2, so that's 1/8. And then I'm going to have 1/4 over times 2, so that'll be 1/8 times cosine of 8x, and I haven't done any integration yet, so it's 1/8 and 1/8 cosine of 8x that I'll have to integrate. Writing out the first couple of terms, they're already taken care of, and then I integrate 1/8 to get 1/8 times x. I integrate the cosine to get sine of 8x, and I have to divide by 8 to account for the 8 that appears here. And we're done with the integration. Notice there are a couple of terms here. There is 1/4 x, there is 1/8 x. They can be combined, and that will be 3/8 of x. Then I have my sine term with the 4x, so minus 1/8 sine of 4x. And then we simplify this term. This is 1/8 times 1/8, so that would be 1/64 of sine of 8x. Let's review what we did. I had an even power of sine. What I did is I broke it apart into multiple factors of sine squared and applied the power reduction identity. When I did that, the angle doubled to 4x. I expanded that expression out as much as I could and tried to integrate those individual terms. However, I was still left with a cosine squared, and that required another application of the reduction identity now for cosine squared. Doing so doubled the angle 4x to 8x, and after expanding that expression out, I was able to integrate term by term.